Okay, today I'm going to be talking about Lab 2 Line of Charges Lab. So, to start off, the introduction is the purpose of this lab is to model the tapes as line charges compared to the point charges which we assumed in Lab 1. Therefore, we are able to obtain a more accurate value of the net electric force from the bottle tape, causing the top tape to levitate. The fundamental principles discussed in this lab are Coulomb's law, as shown for the electric force, law of conservation of charge, establishing that charge can only be changed or can only be moved, it cannot be destroyed, as well as Newton's third law, requiring that every reaction has an equal and opposite reaction. So here we have a quick refresher of Lab 1, establishing that uh, both tapes must be negative in their charge, as well as showing a diagram of us floating the tape. Here we have the initial conditions as gathered from Lab 1. The length 19.5 centimeters, mass 1.95 times 10 to the negative fourth kilograms, 2.7 centimeters distance between tapes, gravity of 9.8 meters per second squared, as well as the electric constant. Over here we have our assumptions. Each piece of tape has an identical charge, as well as the fact that air resistance is going to be ignored. Here we have our initial calculations for the lab, establishing such forces such as force of gravity, as well as that initial Q value of negative 1.2447 times 10 to the negative eighth coulombs. Here we have the second calculations, where we get 9.44 times 10 to the negative ninth coulombs, which is the established line charge value, which is clearly smaller than the initial point charge value. Here we have the initial code for part one, in which we have our constants as well as a function for the electric field. Here we have the functions establishing the line charges for the model at the top, and then down more towards the bottom. We have the positions of that top tape as established with a separation of uh, 0.027 meters or 2.7 centimeters, as well as the bottom tape at a position of 0, as well as the number of charges which we've established as 8 in the program. Now over here we have code 3, which is going to establish the scale for the electric field vector arrows, as well as the net electric force's direction, and the scale for the force electric, also establishing that the force gravity is equivalent to the scale of the force electric. Here we have the code for part 4, in which we have the DQ of the top tape, DQ of the top tape, as well as establishing the arrow for that DQ of the top tape. We also have the electric field due to the on the top to the bottom. More towards the bottom, we have the axis and positions of the arrows for force electric, as well as force gravity, and then we have the printed values of for the magnitude of force electric force as well as gravitational force. Over here, we have our VPython model as established with the code, with that white arrow being the necessary forces, as well as all of the line charge forces being those green arrows pointing down. We now discuss the systems of surroundings, which include the Earth, as well as tape A and tape B, and we have the discussion. So we have that original value of, or what if you had modeled each as a single point compared to a line charge. So the original would have been Q equal to negative 1.2447 times 10 to the negative eighth. However, that updated number is going to be 9.44 times 10 to the negative ninth, which is clearly smaller. So why are these estimates different, and which is more closely to the real value? They differ because for the line charge, all of the charges are spread out and experience less net electric force, requiring there to be requiring it for it to be lesser or a greater charge to keep the tape in equilibrium as compared to the point charge. So the line charge has a smaller value due to there being more distance, as well as cosine and sine values being established for the line charges. It is also more accurate because establishing that there are numerous, in this case n, number of charges throughout those lines of tape compared to a single point charge is more realistic with compared to charges in real life than the point charge model would have been. Now we have possibilities of error. Possibilities of error could have come from limitations of slight inaccuracies while measuring, as well as handling of tape causing a slight transfer of charge, but it largely just based on human error. Now, the conclusion here is that we have demonstrated in this lab that I am able to model charges in a line, as well as use that E equals KQ over R times root R squared plus L over 2 squared times R hat value. And here we have the results of that line model. Q equals negative 9.44 e to the negative 9 coulombs. Thank you.